Hello to all. So I'm back with another topic on logic gates, and it is universal logic gates. We have already talked about basic gates and or and not, and today we will be discussing about two universal gates. Those are NAND and NOR gates. Now, why these gates are called universal gates? Because these can implement any Boolean function without need to use any other gate type. Also, these are economical and easier to fabricate and are basic gates used in all IC digital logic families. We'll get to know why it is so. So let's get started. Before moving forward, let's get familiar with these two gates. Now, NAND gate is formed by combination of and or NOT gate, or we can say that NAND gate is simply an inverse of AND gate. Inverse means a complement. That is, if we are getting 1, inverse of 1 will be 0. So we can see here, as in this truth table, I have already made a video on AND gate earlier. So if you haven't watched it, so I have added the link to the description. So if you get any doubt, watch it so that you can easily connect to the AND gate. So here we can see that in case of AND gate, output gets 1 only when both the inputs are 1. Can see that the output of both of these are complement of each other. Now, two input NAND gate is a digital combination logic circuits that performs the logical inverse of the AND gate, or in other words, we can say that it is the combination of AND and NOT gate, as we have already seen. Now, if we apply two different signals as input of the NAND gate, then the output of this gate can be shown as below. So A and B are shown as two pulses, gate pulses, and corresponding output is seen. So we have already seen that for NAND gate, if both the input are 1, we get output as 0, and for other cases we get output as 1. So we can easily see that wherever both the inputs are 1, we get 0, and in other case we get 1. Okay, so now NAND gate can also be implemented using diode and transistors. If both the input are 0, or if any one of the input is 0, then in that case that diode gets forward biased and the 0 input travels to the transistor, making it off, and in that case this 5 volt can be seen at the output, giving as output high. But if both the input are 1, then these diodes are reverse biased. In that case, this 5 volt can is applied directly applied to the transistor, making it on, and in that case output gets grounded and we get output as low, that is 0, hence satisfying the NAND gate condition. Now it can also be implemented only using two transistors. So here, if any one of the transistor is input is 0, then transistor becomes off, giving an open path here. So in that case again, only this 5 volt can be seen here, output giving as high. And but if both the input are 1, then in that case this transistor becomes on and the output gets a short path, gets grounded, and we get low output. Okay, now it can also be implemented using CMOS. It is the easiest of digital logic operators to implement using transistor technology. Example, a 2 input NAND gate uses only 4 transistors when implemented in CMOS. And for any other gates, if you want to implement using CMOS, then more number of transistor will be required. Say for AND gate, we can also say in this way that AND gate is inverse of NAND gate. So we need to add one inverter here, okay, which will add 2 more transistor and giving a total count of 6 transistors. So a NAND gate can will use on the minimum number of transistors, that is 4. That's why it is easy to fabricate. Now the IC for NAND gate is 7400 quad 2 input IC, Okay, quad means 4 NAND gate will be there. Now these are the specifications given for these ICs, and application of NAND gate are freezer warning buzzer, light activated theft alarm, automatic watering system. So basically NAND gate is used to detect any kind of intrusion or any kind of theft. This is a very important slide because it shows NAND gate you being used for to implement other gates, and I have added one more extra column here to show a simplification so that you can easily connect that how this conversion is being happened. Like for NOT gate, this is the symbol, and using NAND gate, this is how we can implement it. And you can see in the simplification here that NOT gate is expressed as a bar, which can also be written as a dot a complement. So here we can see a and a complement mean this is NAND gate, which is again equivalent to this. So this is how the conversion is being done. Similarly for other gates, and or and XOR, and for if you want to say if you want to implement NOR gate, then in that case we simply add one more NAND gate in front of this OR one. Okay, we get NOR, and for XNOR we add a NAND gate in front of at the end of these XOR gate. So this is how we get all the gates are using NAND gate. Now NOR gate, again this has the similar concept, that is OR gate plus NOT gate gives NOR gate, and we can see here we get output as high for OR gate when any one of the input is 1, and inverse of that gives output 0 when any of the input is 1. So here we can see that both the output for output of OR and NOR gate are inverse of each other. Now NOR gate is a logic gate which gives low output when any input signal is high. The NOR gate can be said is a combination of OR gate and NOT gate. Now again here shown a pulsed operation when two input are shown as these two pulses, and this is the output. Any one of the input is 1, we get 0. So here 0, here input, this input is 1, so 0. Both the input are 0, we'll get 1. Any of the one of the input is 1, then we'll get 0. We can see here. Now this is the internal circuit design of two input NOR gate using transistors. So here if any one of the input is high, then output gets a path either from here or from here. So in both the cases output gets grounded and we get output as low. But if both the input are 0, in that case transistors are completely off, then this VDD will be seen here at the output because only this is the path left and we get output as high. Now this is the implementation of NOR gate using CMOS. Again only 4 transistors are used here, and for other logic gates, implementing other logic gates using CMOS, more number of transistors will be required. Now 7402 is the NOR gate IC, and the applications it is used to construct some real-time applications, and one such application is in mixer tank. Again this slide shows the implementation or realization of gates using NOR gate, and this shows the simplification. Please go through this slide, and if you get any doubt then please ask me. Now an important point to remember here. We prefer NAND gate over NOR gate to design basic logic circuit because area occupied by NOR gate is more than that of the area occupied by NAND gate. As the occupied area is high, capacitance associated with the NOR gate is also high. This causes to occur more delay as the time required for the input to reach output becomes high. But we know that we generally try to avoid such delays, so that's why NOR gate cause more delay and also cover more area, so we generally prefer NAND gate. So that's all. Hope you like the content and video, and if you do, please like and share the video and also subscribe to my channel. Bye to all, take care.